Hello, today we are going to discuss the symmetry and group theory lecture number 3. In this we are discussing about the symmetry elements and operations. Today we will discuss the fourth symmetry element, that is center of symmetry or inversion center, and the improper rotation of axis, that is Sn. Fourth symmetry element is the center of symmetry or inversion center, that is represented by I. This is an imaginary point in the center of the molecule. It may be a point or an atom through which the reflection of each atom can be carried out to result in its coincidence with an equivalent atom. In other words, if any atom in the molecule is connected with the center of symmetry and extended equally on other side, it meets another equivalent point. The center of symmetry is the element and the process of reflection through it leading to an equivalent orientation is a symmetry operation. Center of inversion can be explained by this octahedral structure. This is the central atom and these are the 6 atoms: 1, 2, 3, 4, 5 and 6. If we take the reflection of each atoms through this atom, then we will get this. All the atoms of this will be exchanged, that is for space of 1 there will be 6, and at the place of 6 it will be 1. Now this is the 3, this is the 5, this is the 2 and this is the 4. So here this is the case when the center of inversion is an atom. Now we can explain the center of inversion by this octahedral model. This is the octahedral structure, this is the central atom, and these 6 are the other atoms situated at the corners of an octahedral. Now if we take the reflection of each atom through this atom, the position of each atom will be exchanged and that will be the equivalent structure. So this is the case when the center of inversion is an atom. The another example of inversion center in dichloroethane, that is C2H4Cl2. This is the structure of this dichloroethane. So these are the 2 chlorine atoms and these are the 4 hydrogen atoms. If we connect the opposite atoms, then suppose this hydrogen and this hydrogen, this hydrogen and this hydrogen, this chlorine and this chlorine, so they will cut at this the center of this bond axis. So this is the center of inversion. So here this is the case when there is inversion center is the point, and we will get the reflection of each atom through this point. We will get the equivalent structure. When inversion is operated n times, we have identity when n is even, I when n is odd. This is the model of dichloroethane. These red balls are chlorines and these 4 white balls are the hydrogen. These 2 are the black ball are the carbon atom. So this is the structure of dichloroethane, and each atom, this chlorine and this chlorine, are in transposition. So and this is the center of inversion. This is the point by which we can take the reflection of each atom. So if we take the reflection of this chlorine atom, we will get this position, and this reflection will get this position. Similarly, these hydrogens, this and this, the reflection of this will be this. So the exchange of each atoms will take place when we take the reflection of this center. This is the case of when the center of inversion is point. Inversion versus C2. Sometimes it is confused that the C2 operation and inversion is the same operation, but they are not the same operation. We can explain these two operations by taking this diagram. So this is the ethane molecule, this is the molecule, and this is the inversion center. So if we take the reflection of this and this, they will the position of A and D will be exchanged. Similarly, the position of B and C will be exchanged. So this will be the structure when inversion operation takes place. Now when C2 operation takes place, when we rotate C2 by this axis, that is perpendicular to this bond axis, then this B and D will come to this side and A and C will come to this side, but these are not the same structure. So we can say that the inversion and C2 are two different operations. The fifth element is improper rotation and SN axis. Improper rotation is a combination of two operations: proper rotation, that is Cn, and reflection, sigma h. Improper rotation about n axis, that is 360 degree by n, followed by a reflection through a plane perpendicular to the axis sigma h. So Sn is equal to sigma h Cn. So this operation will be carried out first, and this operation will be carried out the next. Now this is the improper rotation in tetrahedral molecule. This is the tetrahedral molecule, and this is the one atom, and these are the four same atoms. We have marked these four atoms, that is A, B, C and D. Now in tetrahedral structure, this A and B, two atoms are in the plane of the screen, and this C and D is perpendicular to the plane of the screen. Now if it is rotated by C4, then this C and D will come out in the plane of the screen, and this A and B will be opposite to the screen. This will be the position after carrying out the C4 operation. When the reflection sigma h perpendicular to this axis, then we will get the A and B will come here and C and D will be here. So this C and D will be again in the plane of the screen, and A and B will be perpendicular to this screen. So this is the equivalent structure of this. So this is the improper rotation in tetrahedral molecule. This is the tetrahedral molecule, and we can explain the improper rotation of axis. That is, if we rotate this molecule by this axis, that is between these two atoms, and passing these two atoms by 90 degree, that is C4 rotation, then the structure will be like this. Now if we take the plane perpendicular to this axis of rotation, then we will get the reflection of this and this. So this will be the position. So this is the equivalent orientation than the original position. So this is the S4 example. S1 and S2 improper rotations are equivalent to sigma h and I respectively. This is S1 operation, and for this we will take a V-shaped molecule, and then if we rotate this molecule by this axis by 360 degree, then we will get the same thing. And when we take a reflection perpendicular to this axis like this, so this will be the position of these atoms will be exchanged, and this is the same as sigma. In S2 operation, if we take a linear molecule, this is the center of inversion, and if we rotate this molecule by 180 degree, then the position will be changed. And if we take the reflection through this, the this will be the, again we will get the position, and this will be the I equivalent to I. So S1 is equal to sigma and S2 is equal to I. Now we are going to compare between the S4 operation and C4 operation. This is the octahedral molecule, and this, in octahedral molecule we mark all the 6 atoms like this: X1, X2, X3, X4, 5 and 6. If S4 one operation is taken place, then the upper part will be X2, lower part will be X1, and this is X3, X4, X5 and 6. S4 two operation is taken out, then X1 will be in the upper part and X2 will be in the lower part, and this is X3, X4, X5 and X6 will be there. If S4 three operation is taken out, then again the X2 will be in the upper part and X1 will be in the lower part, and X3, X4, X5 and X6 will be there. If we take the S4 four operation, then X1 will be in the upper part and X2 will be in the lower part, and there X3, X4, X5 and 6. So this structure is the original structure, that is the identity. And now we can see that if the N operation is even, that is S4 2 and S4 4, we can see that these S4 operation are equivalent to C4 operation, and when N is odd, that is X1 and X3, these operations are the different operations. So if compared with C4 operation, it is found that S41 and S43 give different orientations from C41 and C43, but S42 and S44 gives the same orientation as C42 and C44, that is identity C44 and S44. Since S1 is equal to sigma S and S2 is equal to I, the order of improper rotation N must always be larger than 2. Generally, when N is even, there are N operations from S and 1 to S and N, while N is odd, there are 2N operations, that is S and 1 up to S and 2N. The operations generated by S6 and S5 axis separately are as, because this is the N is even and this is N is odd. The 6 operations generated by S6 axis are S6, S62, because it is even, so it will be equivalent to C3. S63, that is equivalent to S2, that is I. S64, that is equivalent to S32, it is also equivalent to C32, because it is also an even number. S65 and E, this is for the when N is even. The 10 operations generated by S5 axis are S5, C52, S53, C54, sigma H, C5, S52, C53 and S59 and the identity. S6 axis and operations it generates. See, this is the rotation angle, this is the operation, and this is the symbol. So if rotation is 2 pi 6, this will be the operation S6 equal to sigma C6, symbol will be S6. If the 2 into 2 pi 6 is the rotation angle, then the operation will be S62 and it is equivalent to C62 is equivalent to C3, so the symbol will be C3. If it is 3 into 2 pi 6, then the operation will be S63 is equal to S2 is equal to I. Symbol will be I. When the rotation angle is 4 into 2 pi 6, the operation will be S64. This is equivalent to C32 and the symbol will be C32. If the rotation is 5 into 2 pi 6, the operation will be S65. This is equivalent to sigma C65 and the symbol will be S65. And if the rotation angle is 6 into 2 pi 6, the operation will be S66, that is identity. The symbol will be identity. As 5 axis and operations it generates. This is the table for S5 operations. So if the rotation angle is 2 pi 5, operation will be S5 is equal to sigma C5. The symbol will be S5. If the rotation angle is 2 into 2 pi 5, the operation will be S52 is equal to C52. The symbol will be C52. So this will be the 10 operations, and in the 10th operation there will be the identity. By studying both the tables S6 and S5 operations, so the following relations are helpful in this regard. So first, A is if n is even, S and n is equal to identity. If n is odd, then S and n is equal to sigma h, and S and 2n is equal to identity. Third, C, if m is even, then S and m is equal to C and m when m is less than n. If S and m is equal to C and m minus n when m is greater than n. If Sn with even n exists, then Cn oblique 2 exists. If Sn with odd n exists, then both Cn and sigma perpendicular to Cn exist.